Okay, so you missed lesson 4.2.4. It's some extra practice and some new tips with how to balance chemical reactions. So for this first one, let's do an atom inventory. We've got sodium, hydrogen, carbon, and oxygen all involved. It's a good idea to write down the elements that you have underneath the arrow so that you can start by conducting an atom inventory like we learned in the last lesson, and just count up how many atoms of each type you have on each side. I've got 1 sodium on each side, 1 hydrogen on the left, 2 on the right, 1 carbon on the left and 2 carbons on the right, 3 oxygens on the left and 3, 4, 5, 6 oxygens on the right. Before we go any further, let's also check that the compounds are written correctly. So it says that sodium bicarbonate, that is correct, forms sodium carbonate, carbon dioxide, and water. I know carbon dioxide and water look correct, but sodium has a +1 charge and carbonate has a -2 charge. So when you crisscross, this should actually be Na2CO3, which means that we'll need a little correction before we start balancing. If your reaction is written incorrectly, sometimes it's impossible to balance, literally impossible. So that's something that is always good to check. Is the correct reaction written before you start? So never start with H's and O's. Start with something else. So here we could start with the sodiums. I need to put a 2 on the left side so that my sodiums are now balanced, but that changes my hydrogens, my carbons, and my oxygens. In this case, it made everything perfect because now the numbers to the left and right are the same. Let's check out the notes for how to balance an equation. It says first, make that atom inventory, which is what we just did. Then, identify an element that does not have the same number of atoms on each side. We used sodium, for example. Add a coefficient, which are the numbers out front, to correct the imbalance. Then, update your atom inventory. Make sure to recount all of your atoms every time you add a new coefficient. And then keep repeating until everything is balanced. Some more tips, like I was saying. Save the hydrogens and the oxygens for last. If a polyatomic ion, like phosphate, shows up on both sides, you can treat it as one element. Never, ever change the subscripts, assuming they're written correctly. You can only change the coefficients when you're balancing. Make odd numbers even is often a good tip. So KClO3, that's 3 oxygens, and that's odd. If you put a 2 out front, it'll make it 6. If a reaction only has carbons, hydrogens, and oxygens, you can balance in that order. That's the right way to do. So carbons first, hydrogens second, and oxygens third. And last, sometimes it's helpful to use a decimal temporarily as a coefficient, and then you double everything at the end to show whole numbers, because you can't leave a chemical reaction, even if it is balanced, with a decimal for a coefficient, because you can't have like 1.5 water molecules, for example. So let's look at the activity. It says first work on balancing a few together, and then balance on your own. So there are a total of 10 reactions here to balance. I recommend pausing the video after the first couple and seeing what you can do on your own. So this one has carbons, hydrogens, and oxygens. So we want to balance in that order. 3 carbons on the left, 1 on the right. 8 hydrogens on the left, only 2 on the right. 2 oxygens on the left, and 3 on the right, because there are 2 in that carbon dioxide and 1 in the water. So let's start by balancing the carbons. If I put a 3 in front of the CO2, my carbons are now balanced, and my oxygens are up to 7. Let's do the hydrogens next. let's do a 4 out front of the H2 so that now we've got 8 hydrogens, and now we've got to add up all of our oxygens. 3 times 2, that's 6 oxygens here, 4 oxygens here. That makes a total, it looks like 60 and 40. I'll put oxygen. That makes a total of 10 oxygens on the right side. So now I'm going to need a 5 in front of the O2 to make it 10 oxygens on the other side. And you can leave this a blank or you can put a 1 in. It's just up to you. How about the next one? We've got hydrogens. The sulfate stays together so we can treat it as one atom. We've got Na, and Cn is another polyatomic ion that stays together. 2 hydrogens on the left, only 1 on the right. 1 sulfate on the left, 1 on the right. 1 sodium on the left, 2 on the right. 1 Cn on the left, and 1 Cn on the right. Okay, let's see what we can do here. So I'm going to start with the NAs because it said not to start with the H's, and the NAs also are not balanced. So if I put a 2 there, now I've got 2 Na and 2 of the Cn. So now on the other side, I'm going to need a 2 in front of the Cn to balance that, which also helps my H's out. Now everything is balanced. So 1, 2, 2, 1. For number 3, I've got potassium, nitrogen, and oxygen. I can't keep the nitrate together because it separates. I've got 2 potassium on the left, 2 on the right. 1 nitrogen on the left, 2 on the right. 3 oxygen on the left, and only 1 on the right. So we're going to need to do some balancing here. Let's start with the nitrogens. Since there are 2 on the right, if I try putting a 2 in front of the KNO3, now I've got 2 nitrogens, and I've also got a weird number of potassiums. 3 potassiums. I've got 6 oxygens now. So this isn't really helping because now I'm definitely going to need to do something else here to try to balance out my potassiums. So I'm going to try something different. I'm going to go ahead and put a, let's see, if I put a 2 in front of the K, that doesn't really help us out because that makes it 4 and the oxygens are still more, 6 oxygens. So what if I try putting a 6 here? Now I've got 6 times 2, I've actually got 12 potassiums, not 6. This is what I meant to change to 6. 6 oxygens and the 2 nitrogens. So I got to go back over to the other side. Everything is balanced now. 6 and 6, 2 and 2, except the potassiums. So I've got 2 potassiums here, and I need 8 more. So if I change this to an 8, or I'm sorry, a 10, now I've got 12 potassiums on the left side and 12 on the right side. So sometimes with balancing reactions, you really need to play around with it. Oh, number 4 looks a little easier. It's just got K and I. 1 K on each side, and the I's are not balanced. So I'm going to need a 2 in front of the KI, which means that that fixes my I's, but now my K's are off. If I add another K on the left side and put a 2 out front, now everything is balanced. Number 5, I've got K, Cl, and O. I've got 1 potassium on each side, 1 chlorine on each side, and my O's are off. This is a good one where we can make odd numbers even. Throw a 2 out front to change that oxygen to be 6 instead of 3, and now my potassium and my chlorines are both 2. So I'm going to need a 2 in front of my KCl and a 3 in front of my O2 so that that makes it 6. Remember, if it's only carbons, hydrogens, and oxygens, you're supposed to balance in that order. I've got 2 carbons on the left, only 1 on the right, 3 hydrogens on the left, 2 on the right. Oops, I meant 6. I've got 2 oxygens on the left and 3 on the right. So let's start with the carbons. If I put a 2 in front of the CO2, that helps out my carbons, and now it made 5 oxygens. For the hydrogens, I need a 3 out front to make that 6 hydrogens, but now I've got 4, 5, 6, 7 oxygens. Temporarily, I can use a decimal. I can make this 3.5 to show that I've got 7 oxygens, but I can't leave it that way. I'm going to erase this one above it so I have a little bit more room. There's a 1 in front right now, but what I'm going to have to do is multiply all of the coefficients by 2 to get my final answer. 2, 7, 4, 6, because they have to be whole numbers. Now if I want to go back and re-add up how many elements are on each side, it should work out without having to use a decimal. I've got 4 carbons on the left and right. I've got 12 hydrogens on the left and right. I've got 14 oxygens on the left. 4 times 2, I've got 8 oxygens, plus another 6 oxygens. That's 14 oxygens. Only aluminum and oxygen in number 7. 1 aluminum on the left, 2 on the right. 2 oxygen on the left and 3 on the right. Remember the trick, make odd numbers even. So I'm going to put a 2 in front of that Al2O3, which makes 6 oxygens and 4 aluminums. Now I need to fix up my aluminums on the left, as well as my oxygens. 3 times 2 is 6. Now I've got 4 aluminums on each side and 6 oxygens on each side. Number 8, I've got magnesium, hydrogen, and oxygen. 1 magnesium on each side, 2 hydrogen on each side, 1 oxygen on each side. Could it be true? It's actually already balanced, so we don't need to add anything. Happy day. If you want, if it makes you feel more satisfied, you can add 1s. Lithium, hydrogen, oxygen. 1 lithium on each side, 2 hydrogens on the left and 3 on the right, 1 oxygen on each side. Oh, so close. So we know that we're going to need some more hydrogens over here. If I add a 2, it makes it 4, and it also doubles my oxygens. So on the other side now, I'm going to need to double my oxygens, which turns my lithiums into 2, my hydrogens into 4, because 2 hydrogens here plus the other 2, and then I've got 2 oxygens. So now to fix this, I just need a 2 out front of my lithium. So to balance it, it would go 2, 2, 2, 1. And my last one, I've got hydrogens, I've got phosphates, which stay together, I've got calciums, and I've got hydroxide. Technically, if I write this out to be HOH instead of H2O, I can use this to my advantage because I can count that OH as having stayed together. So I'm going to do that. We'll actually balance this one twice. We'll do it in 2 different ways. So right now, for just the plain old hydrogens, I've got 3 on the left, and I've got just 1 on the right. For phosphates, 1 on the left and 2 on the right. 1 calcium on the left, 3 on the right. And the OHs that stayed together, I've got 2 on the left and just 1 on the right. Here's my OH on the right. Okay, so let's not start with the H's or the O's. Let's start with the calciums. I'm going to put a 3 in front of the calcium on the left side, which actually makes this 6 OHs. Now for my phosphates. If I put a 2 out front, I've got 2 phosphates now, but I've also got 6 hydrogens. So I'm going to need to put something out front of my HOH. If I put a 6 there, now I've got 6 of that first hydrogen, and I've got 6 OHs. So everything is balanced. Now, if that was confusing for you to keep the polyatomic ions together, let's do this reaction one more time without keeping them together. So you've got H, P, O, Ca. Is there anything else? That's it. 3 hydrogens on the left plus another 2. That makes 5 hydrogens. On the right side, there's only 2. 1 P on the left. PO4, 2. That makes 2 P on the right. 4 oxygens plus another 2 oxygens makes 6. There's 8 oxygens plus a 9th one on the right. 1 calcium on the left and 3 on the right. So let's start with calciums again, because it's not an O or an H, or I could have started with the phosphorus. Put a 3 in front of my calcium. That adds some more oxygens. 3 O2s makes 6 plus another 4 oxygens. That's 10 oxygens now. And that's 6 hydrogens plus that original 3. That's 9 hydrogens. So that got us somewhere, but we're not there yet. So what if we add that 2 in front of the H3 to get our phosphoruses in line? Now we've got 6 hydrogens there plus the other 6, 12 hydrogens, plus we've got 2 P's. That's good. Did I cross that one out too early before? Anyways, we've also got 6 O's plus another 8 O's. What is that? 14 O's. So we're going to need to add some more H's and some more O's, because the P's and the Ca's are the only thing that are balanced right now. If I had a 6 in front of this, that's going to help my hydrogens as well as my O's, because I've got 6 O's plus another 8 O's. So now 12 and 12, 14 and 14, everything is balanced. That's probably the trickiest one. And there's a couple ways to do it. So that should help you with getting started with some of these balancing reactions.